Hello everyone, welcome back. I'm Shikesh and this is experimental physics. So today we are going to see another video and it is about rolling motion, objects that are in purely rolling motion. There is one specific concept in which students usually stuck up. So first we are going to see that concept on paper and then I'm going to show you the proof doing the experiment as usual. So let's go. So the concept today that I want to show you is this. Suppose we have a spherical object who's moving with velocity v naught. Its center of mass has velocity v naught. This is our ground. Okay, it's a horizontal ground, and the object is purely rolling. So there must also be a angular velocity. So suppose this is your angular velocity omega naught. So the object has angular velocity omega naught with which it is moving about this center of mass of the object, point O, right? Now, in such cases, we have equation V naught is equal to R omega naught. So if this equation holds true, we say that the object is purely rolling. Now, there is another concept that I want to focus today, and it is this diagram. I am again drawing the same diagram. The object has v naught velocity at its center of mass. The point which is in contact with the ground is momentarily at rest, and the topmost point has velocity 2v naught. I am quite sure that many of you have seen this particular diagram. In this diagram, we are trying to tell you that this point P, which is the topmost point, has velocity twice than the center of mass velocity, and the point which is in contact with the ground, let's suppose it is point Q, then the velocity of point Q is 0 at that particular instant. So we have a mathematical model for this, we have mathematical proof also, but today I'm going to show you how it is possible. Let's do it. And for this purpose, I'm going to use our simple marker pen, right? This is a marker pen which I'm going to roll on this object, and we are going to demonstrate that indeed this velocity is twice compared to the center of mass. So our setup is ready. As you can see, I have set up a scale here. It's in centimeter, and we also have that marker which is specifically pointing at 30 centimeter point. Okay, I'm going to place my one hand like this on the top of the pen, and I'm going to roll it. Okay, and I'm going to stop when the pen reaches the value of 20 centimeter. It means the pen will travel 10 centimeter from the initial point, right? I want you to check where will be my fingertips at that moment, okay? And that will answer your question. Okay, so I have reached 20 here, and you can see that my fingertips are at 10 centimeter, right? So my fingertips have traveled 20 centimeter. In the same time duration, the pen has traveled only 10. So I hope that you were able to get the distances. Now I'll explain what has happened. When I was rolling this pen, my fingertips were always in contact with the uppermost point of the marker, right? So when the marker has moved 10 centimeter, my fingers had moved 20 centimeter. It means the speed of the fingers was double compared to the speed of the center of mass of the pen, which indeed shows that if center of mass has speed v naught, the topmost point will have, at that moment it will have speed 2 v naught. Similarly, what happens to the point which is at the bottom? We write speed at this point is 0, the bottommost point. Well, think about it. The bottommost point is always in contact with the table when we're doing the experiment. and the table was not moving. So the speed of the table is 0. So speed of this points, all of these points, is also 0. So I hope that this simple experiment clears your whole concept. So I hope that you learned something new today and something that is interesting. You can see that very basic things which we use in daily life, they can teach us physics and complicated concepts of physics, and that's what I like about this subject. Also, actually, I have a story regarding this particular experiment. As many of you know, I was an intern under Professor H.C. Verma, who is a well-known physicist and a well-known author in physics community. He has written Concepts of Physics and many more such books. And I got the opportunity to work with him 2 years ago. And in one of such workshops, okay, he takes many workshops for Kendriya Vidyalaya teachers and other teachers to make them better equipped in teaching. So, in one of such workshops, I attended a segment of another professor, Mrs. Smita Fandaria. She is from Delhi, Delhi Anveshika, and she showed us this demo. Okay, so I got this idea from her, and Dr. Verma has also introduced this concept, this way of teaching ruling motion mechanism in his new book actually. Concepts of Physics has been rewritten, and it is actually, it's a complete new package, but it's in Hindi. Bhautiki ki Samajh, okay, that's its name. And in that book he has included this particular concept, so many of the students and teachers might have seen it there. If you liked our video, please subscribe so that it encourages us to make more such videos. Thank you very much.